Hi, my name is dr. Ahmath. In this video, we are going to quickly review the angles and the trigonometric functions. So essentially, if you're given the rectangular coordinate system, the angle, or as we call this as a standard angle is the set of points between so-called initial line and the terminal line. So the initial line is always going to be here along the x-curve, and the terminal line might change. So it might rotate around the origin to in the clockwise direction or in the counterclockwise direction. And we call this angle as a standard angle. And this angle, for example, might be 30 degrees or 50 degrees or 60 degrees. We're going to measure these angles in degrees. So what does it mean? The degree is that, so the one-time rotation around the origin. So if you just take this terminal line and just rotate this terminal line around the origin, here, this is going to be a measurement of 360 degrees. And if you would like to just measure the 30 degrees, you just need to take some portion of this 360 degrees. So essentially, 1/4 of this portion is going to be 90 degrees, right? And if your terminal line is here, for example, then this angle from the initial line until terminal line is going to be defined as the 90 degrees because it's like 1/4 of the 360 degrees. So at the same time, we are going to define something which is called a reference angle. So this is very much connected with the concept of the standard angle. So again, I'm going to draw the rectangular coordinates. So this is the x, this is the y, and the initial line is always here along the x-axis. So this is my initial line. So let's assume that your terminal line is here. Okay, so this is going to be your terminal line. And the standard angle is essentially going to be defined like here. So this is the standard angle. So you see, so the standard angle now is more than 90 degrees. So the reference angle for the standard angle is always going to be an angle which is not less than 90 degrees. So essentially the acute angle. So this angle phi is going to be called the reference angle. So the reference angle is always less than 90 degrees. So essentially, if you are given the angle to be equal to 120 degrees, right? So we know that half a portion of the 360 degrees, so essentially, if your terminal line would be here, then this angle here, from here until here, would be equal to the 180 degrees. Okay, so if the theta, so this lecture is going to be called as theta, is equal to the 120 degrees, then phi, so this is going to be called as a phi, is going to be equal to the 60 degrees because the sum is equal to the 180 degrees. So essentially, the reference angle for the standard angle 120 degrees is equal to the 60 degrees. So essentially, if the standard angle is equal to the 120, then reference is equal to the 60 because the sum should be equal to the 180 degrees. So at the same time, if the standard angle is smaller than 90 degrees, then the reference angle is going to be the same. So essentially, again, so if your initial line is along the x-axis here, so this is going to be your initial line, and if your terminal line here, so that the angle between them, so standard angle is equal to the 30 degrees, then the reference angle is also going to be 30 degrees. So the standard angle is 30 degrees and the reference angle is also 30 degrees. So essentially, the reference angle is going to be defined when the theta is more than more than 90 degrees, and we need to find the phi by just subtracting the theta from 180 degrees. So, and we can measure the angles using so-called radians as well. And the idea of measurement of the radius is very much connected with the radius of a circle. So essentially, let's say you've got a circle, right? So we know that if you would have an initial line and just rotate this initial line, or just like take a terminal line here, for example, or the set of points between these two lines, the initial and the terminal line, would be called as an angle, right? So one-time rotation of the initial line. So if you just take this initial line and just rotate this initial line around the origin, this is going to be E equivalent to the 360 degrees. And now I would like to define the radians in this way. So let's say you are going to find yourself here, and what you're going to do is you're going to just walk around on the circle, okay? And if you just walk the distance, which is exactly equal to the radius of a circle, for example, if the radius is equal to the 1 meter, then you walked exactly 1 meter, then this angle which you made is going to be equivalent to the 1 radians. Okay, so this is how we are going to define the radians. So let's define how we can. So let's see how we can define the radians for the half circle. So let's say I'm going to draw a circle again. So this is my circle. So I started from here. So this is going to be my initial line, and my terminal line is going to be here. So then the equivalent in terms of the degrees is equal to the 180 degrees. So now I would like to just say, hey, the radius is equal to the 1 meter. So I'm going to start from this point and go along the curve. So I will walk 1 meters, 2 meters, 3 meters. Okay, so it's going to be 1 meter, 2 meter, oops, sorry, and the 3 meters. Okay, and a small distance here. Okay, so the exact value of distance which I can pass through here is going to be equal to this 3 point, oops, so it's going to be equal to the 3.14 roughly. So 3.14 roughly. We call this as a pi. Okay, so you see so that there is a correspondence between 180 degrees and the pi. And it's really important for us to be able to convert this two measurements of angles. So one measurement is about the radians, right? It's like how many radiuses you walk around you walk on the circle. So if you just walk half a radius, for example, half a meter, then this angle is going to be equal to the half a radian. Okay, 1/2 radians. So how we can transfer the radians to the degrees? Convert. So you need to always remember that 180 degrees is equal to the pi radians. And just using this equality is going to help you a lot in finding and transforming the angles. So I'm going to show you how to do this. So if you're given the radians, so for example, let's say you're given pi over 6, how to find the degrees? Pi over 6, what is this degree, right? You need to always try to do the proportion. So you need to write this down. So 180 degrees is equivalent to the pi radians. Okay. Then what is the degree if you're given pi over 6 radians? Right? So this is our problem. In order to solve this, we need to just multiply cross by cross. So essentially, 180 degrees times to the pi over 6 is equal to the x times to the pi, and you need to find the x from here. Okay? In order to find the x, you need to divide both of the parts to the pi. Okay? So let's divide this part to the pi and this part to the pi, and we're not changing the equation, right? By just dividing both of the parts to the pi. If you divide the pi, the left-hand side, so this pi and this pi are going to be cancelled. And on the right-hand side, this pi and this pi are going to be cancelled. And what you have here is x is equal to the 180 degrees divided to the 6, which is equivalent to the 30 degrees. Okay? So the degree equivalent to the pi over 6 is equal to the 30 degrees. So at the same time, we can do the vice versa. So let's say you are given the angle like 60 degrees. So what is its radian equivalence? And again, you need to remember one equation or one correspondence. So 180 degrees is equal to the pi radians. Now you're given the degrees, so I'm going to just write down the degrees on the bottom of the degrees. Now I have to find what is its equivalence in radians. And again, I'm just going to multiply cross by cross. So it's going to be 180 degrees times to the x is equal to the pi times to the 60 degrees. So I need to find the x, so that's why I'm going to just divide both of the parts as a 180 degrees. So I can divide this side as a 180 and this side as a 180. This doesn't change the equation, right? So, and what I get is essentially I can just cancel these things and these things. So what you have is here, x is equal to the pi times to the 60 divided to the 180 degrees. So the 60 degrees divided to the 100 degrees is just simply 1 over 3, right? So that's why it's going to be equal to the pi over 3. And essentially here, the angle which corresponds to the 60 degrees is pi over 3. So this is how we can convert the degrees to the radians and radians to degrees, always using this equation, that 180 degrees is equal to the pi radians. Now let's quickly define the trigonometric ratios. So if you are given the triangle with the right angle, so essentially a triangle which contains the 90-degree angle, then we can define the trigonometric functions in the following way. So you see, so the longest side of this triangle is always going to be in the opposite side of the 90-degree angle, so which we call as a hypotenusis. So now, if you're given this angle phi, and if you're given the lengths of these two sides, x and y, or let me call this as a y and x, then the sine of phi is going to be defined as y divided to the c, and the cosine of the phi is going to be defined as the x divided to the c, and the tangent of the phi is going to be defined as the y divided to the x. So we are going to define the trigonometric functions on these circles. So essentially, if you're given a circle, let me draw this one more time. So if you're given now a circle, I'm going to define the trigonometric functions on the circle. Okay, but please note that it does not necessarily be a unit circle. It's okay that if the radius of the circle is any value. So now along the circle, let's say you are given the point. For example, this point is given as the coordinates 3 and 4. Okay, so again, if you remember, we talked about the initial line, right? So this is going to be the initial line, and the terminal line is always going to be defined as the point. So essentially, I would ask you, hey, could you please tell me what is the angle between the initial line and the terminal line, which is defined with this point? Okay, then you need to define this angle. So this is going to be the phi, and you need to figure out what is going to be the trigonometric values for this, right? So what does it mean that the coordinates of this point is equal to the 3 and 4? So it means that I can make the triangle here. So this triangle, where this side of the triangle is going to be the y coordinate of the point, so essentially 4, and this coordinate of this triangle is going to be equal to the 3. I mean, essentially, this is how we need to define the points on the rectangular coordinates, right? So how we can find the hypotenusis is by just using so-called Pythagoras theorem. So the C hypotenusis is going to be the square root of one side of the triangle in the square, so which is 9, plus another side of the triangle in the square, which is 16, and take the square root, which is going to be square root of 25, or simply 5. So this side of the triangle is going to be equal to the 5, and I need to always find this from the coordinates of the point. So now we are going to define the cosine of the phi as the 3 over 5. Sine of the phi is going to be defined as a 4 over 5, and the tangent and cotangent functions are just defined as the tangent is going to be defined as the 4 over 3, and the cotangent of the phi is going to be defined as the 3 over 4. So now what if your points are given in somewhere else? So for example, if your point is given here, right? You see, so in order to define the cosine, it appears you need to divide the x-coordinate to the radius. In order to define the sine of the phi, you need to divide the y-coordinate to the radius. So if you're given the point here, for example, with the coordinates minus 3 and 4, how we can define the cosine and define of this angle now, phi, of the standard angle, right? So we're going to do this in this way. So you're given the point with the coordinates minus 3 and 4, right? You remember that the cosine of the phi is defined as the x-coordinate of the point divided as a radius, right? And the sine of the phi is defined as the y-coordinate divided to the radius. And you are always going to find a radius by just taking the x-coordinate in the square plus the y-coordinate in the square and taking the square root, which is going to be equal to the 5. So you can just like substitute the 5 to here. So the cosine of this angle is going to be minus 3 over 5, and sine of this angle is going to be equal to the 4 over 5. Again, let's do one more exercise. So example. So I'm going to draw a circle. So let's say you are given some point on the rectangular coordinate system. So this point can be any point. So for example, this point can be given as here. Okay, so the coordinates of this point, let's say, is minus 3 and minus 2. Okay, so now I'm interested to find the trigonometric functions for this angle, phi, let's say. So again, if you remember, we can define the cosine of the phi as the x-coordinate minus 3 divided to the radius, and the sine of phi define it as the minus 2 divided to the radius. And how we can find the radius is that by just finding the distance between this point and the origin, right? Let's do this. The radius is going to be defined as the x-coordinate of this point in the square, which is minus 3 in the square, plus the y-coordinate of this point in the square, which is minus 2 in the square. Then we just need to take the square root. It is going to be square root of 9 plus 4, which is square root of 13. So what I need to do is I just need to plug this 13 to the r instead of r. So the cosine of this angle is going to be defined as the minus 3 divided to the square root of 13. And the sine of this angle phi is going to be defined as the minus 2 divided to the square root of 13. You see, so the x and y coordinates of the points of the terminal point is going to give you the values for the cosine, sine, tangent, and cotangent. But you need to always remember that you need to scale them. So essentially, you need to divide the x and y coordinates to so-called radius, which is simply x coordinate in the square plus y coordinate in the square and taking the square root. Okay, so this was a quick review about the trigonometric functions and the angles. So I hope that this was very helpful.